Hello, and welcome to the HYDAC Australia podcast. I'm glad you're here. In each episode, we share practical insights, technical knowledge, and real-world solutions to help you get the most from your hydraulic and fluid power systems. Let's get started. In our previous episode, we explored the hidden sources of hydraulic contamination. We talked about where contaminants come from, how they enter a system, and why keeping oil clean is one of the most effective ways to improve machine reliability. But that raises an important question. When someone says an oil sample is clean, what does that actually mean? How clean is clean? Is there a universal way of measuring cleanliness, or is everyone simply making their best guess? Fortunately, there are recognized industry standards that allow us to measure and report cleanliness in a consistent way. In today's episode, we're going to explore how industrial cleanliness is measured, the standards used across the industry, and why understanding these measurements is an important part of managing hydraulic systems. Let's dive in. When discussing contamination, it's easy to think in general terms. We might say, one system is cleaner than another, or that a machine needs cleaner oil. But engineering doesn't work particularly well with vague descriptions. We need numbers. We need a consistent method that allows one engineer, one laboratory, and one maintenance team to interpret cleanliness exactly the same way. That's why cleanliness standards exist. They provide a common language for measuring the amount of contamination present in a lubricant. Although there have been several standards developed over the years, 3 have become the major ones discussed within the industry. They are NAS 1638, AS 4059, and ISO 4406. Let's start with the oldest. NAS 1638 was originally developed as a national aerospace standard and first published back in 1964. Its purpose was to classify particles in a fluid according to different particle size ranges. The process involved separating particles into groups based on their size, counting how many particles appeared within each group, and then assigning a cleanliness class. For many years, this served the industry well. However, standards evolve just as technology does. NAS 1638 has been inactive since 2001 and is no longer regarded as the current standard. That doesn't mean it has completely disappeared. You may still find it referenced in older publications, technical documents, or even some existing products, but for modern applications, it has largely been replaced. That brings us to AS 4059. This standard replaced NAS 1638 in the early 2000s and introduced a simpler approach to particle classification. Instead of counting particles that fall between specific size ranges, AS 4059 counts particles that are greater than a nominated size. At first glance, that might sound like a small difference. In practice, though, it makes the classification process much easier. Rather than stopping at one particle size, changing categories, and starting again, the counting process becomes more straightforward and easier to apply consistently. AS 4059 also groups particle sizes into classifications identified by the letters A through F. As particle size increases, the acceptable number of particles naturally decreases. That makes sense. Large particles are generally less common, so if they're present in significant numbers, they're likely to attract attention very quickly. One interesting point about AS 4059 is that, although it's officially known by that designation, many people simply refer to it as the SAE standard because it's published by the Society of Automotive Engineers. It's one of those little quirks of industry terminology that often causes confusion, especially for people encountering it for the first time. Now let's move to the standard you're probably most likely to encounter today, ISO 4406. If you've ever received an oil analysis report or worked with hydraulic cleanliness specifications, chances are you've seen an ISO 4406 cleanliness code. This international standard has become the most widely used method for reporting hydraulic cleanliness. One reason is simple. It's an international standard. Whether you're working in Australia, New Zealand, Europe, North America, or many other parts of the world, ISO 4406 provides a common way of communicating cleanliness levels. That consistency makes collaboration much easier across manufacturers, laboratories, and maintenance teams. But there's another reason why it has become so popular. It's simply easier to use. Unlike the earlier standards, it uses a single numbering system that applies consistently across the particle sizes being evaluated. Rather than working with several different charts depending on particle size, engineers use the same classification structure throughout. The numbering system itself is also surprisingly logical. Each cleanliness class represents roughly double the number of particles of the class below it. As particle counts increase, the classification number increases as well. This creates an exponential scale. At the lower end, the numbers represent only a handful of particles. At the upper end, they represent millions. That sounds dramatic, but it allows an enormous range of cleanliness conditions to be described using a relatively simple numbering system. There's another interesting characteristic of this scale. Imagine you're flushing contamination out of a hydraulic system. Initially, you may remove a very large number of particles, yet the cleanliness code barely changes. Then, as the system becomes progressively cleaner, relatively small improvements can cause the cleanliness code to change much more quickly. That's simply the way the classification system works. It's not that filtration suddenly becomes more effective, it's just the mathematics behind the cleanliness scale. From a practical point of view, many people don't need to understand every detail of how the numbers are calculated. What matters is knowing how to interpret them. A useful way to think about ISO 4406 is much like a game of golf. In golf, everyone understands that the lower the score, the better. Hydraulic cleanliness works in much the same way. The lower the ISO cleanliness numbers, the cleaner the oil. You don't necessarily need to understand every mathematical calculation behind the standard to appreciate what a lower cleanliness code represents. Sometimes, keeping it simple is exactly what makes a standard so effective. In the next part of this episode, we'll move beyond the standards themselves and look at something equally fascinating. How do engineers actually count particles that are far too small to see with the naked eye? We'll explore the techniques used in laboratories, how automatic particle counters work, and why taking a good oil sample is just as important as analyzing it. Thanks for listening to the HYDAC Australia podcast. If you enjoyed this episode, be sure to follow the podcast and share it with your colleagues. For more technical resources and product information, visit hydac.com.au. Thanks for listening and see you in the next episode.